Example number 3. In the diagram, we know these two triangles are similar. Find the value of x and the scale factor of triangle DEF to triangle MNP. Okay, so first of all, let's go ahead and find our scale factor. We know the triangles are similar, and so I know that DE to MN will give us our scale factor since we know they're similar. So, and those are corresponding sides, so we have 9 to 12. Which simplifies to 3/4. So there's our scale factor right there. And we can check to make sure that it is the same with our other known sides. So we also know that DF is corresponding to MP, which is 12 to 16, which simplifies to 3/4. So we can see that 3/4 is our scale factor. To find that x value, now watch very carefully. This x is marked by EF. So I'm going to set up the following proportion. I know that EF to its corresponding side NP should equal my scale factor. So I can use either one of the ones I used to find it. So this proportion should be true. So EF is x, NP is 20, and our scale factor is 3/4. So now I'm going to solve that to find my x value. So I'm going to cross multiply. So I have 60 equals x times 4, so 4x. I'm going to divide both sides by 4, so x equals 15. So what I did there is I found my scale factor, and then I set my scale factor equal to some sides that should have a ratio that is same as the scale factor. And we'll do a couple more examples like that. All right, let's go ahead and look at perimeters. If two polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding side lengths. So basically, if I add up all the sides of one of my triangles, and I divide by the sum of all the sides of my other triangle, it should give me that scale factor that I get from dividing any of my corresponding sides. Now, if the two polygons are similar, then the ratio of any two corresponding lengths in the polygons is equal to the scale factor of the similar polygon. So read that really carefully. You might want to pause and just read through that and make sure that that makes sense. The ratio of their perimeters is equal to the ratios of their corresponding side lengths, which is their scale factor. Okay? All right, last example. And I'm going to kind of zoom in and around on this one. So let's start with just this first part. I'm going to move this out of the way a little bit. Okay, so example 4. In the diagram, we know that these two polygons are similar. Now, notice that these are not facing the same direction. Feel free to redraw it if that helps you so that they are facing the same direction, or just really rely on this similarity statement. So first it asked me to find the scale factor of JKLM to EFGH, and so I'm going this way right here. So anytime I'm setting up a proportion, I want to start with this triangle on the right, and then I want to go to the triangle on the left. Okay, so to find my scale factor, I just really need any sides that I know the lengths of on both polygons. So for instance, I know JK and I know EF, so I'm going to use that to find my scale factor. So I'm going to do JK over EF. JK is 20, EF is 8, and I got that from JK, EF in my similarity statement. So 20 over 8 simplifies to 5 over 2. That's going to be my scale factor that I'm using here. To find x, I'm going to set up a proportion. And so I'm going to do, for my x, I'm going to do, that's KL, which is corresponding to FG. So I'm just going to make myself a note of that. So KL to FG, which is 11, should equal that scale factor. So remember, the ratio of any corresponding side should equal that scale factor. So I set up my proportion, and then I'm going to go ahead and cross multiply. So 55 equals x times 2, divide by 2. So 27.5 is our x value. Okay? All right, now I'm going to make that small and make this a little bit bigger. Okay, so now I'm going to find my value of x. So my value, or my value of y. I'm going to do the same thing I did before. My value of y is on EH, which corresponds to JM. So I'm just going to make myself that note. So EH, and I'm going to stop, and I'm kind of glad I did this. I didn't do it on purpose, but I made a mistake here because remember we said that when we're setting up our ratios, we need to go from the right to the left, and I just went from the left to the right. So let's undo that. We got to flip that upside down. We got to start with the one on the right. And so if I want EH, then I need to start JM over EH. I hope that makes sense. We got to go right to left with these polygons here, okay? So JM to EH. So my JM is 30. My EH is y. We don't know what that is. And it should equal that scale factor 5/2. So I set up that ratio, that proportion, and I'm going to cross multiply. So I multiply 5 times y and 30 times 2. And then I'm going to divide both sides by 5. So my y equals 12. Okay, so I have my x, I have my y. We can fill those in up here if we want to. We know our y is 12, so I'm going to go ahead and put that here. And we knew that our x was 27.5, so I'm going to put that here. Might come in handy a little later. Oh, and I moved all my text. Sorry about that. Okay, so then I'm going to find my value of z. Well, z corresponds to angle E, and angle E is corresponding to angle J. Angle J is equal to 65 degrees, which means that z is equal to 65 degrees. So that one's kind of easy. All right, find the perimeter of each polygon. So this is, we have to go back to, if you just look up at your definition of perimeters of similar polygons, the ratio of the perimeters is equal to the ratios of their corresponding side lengths. So the ratio of their perimeters is equal to the scale factor. So I don't know the perimeter of this, so I'm going to say P. I don't know what it is, but I do know the perimeter of this. I can add up all 4 of those sides. 12 plus 3 is 15, plus 11 is 26, plus 8 is 34. So I did the ratio of the perimeter of the polygon on the right to the ratio, or to the perimeter on the left, equals my scale factor. And then I'm just going to solve this proportion. I cross multiply, and so I have 34 times 5, sorry about that, which is 170, and then P times 2, so 2P. I'm going to divide both sides by 2. And so 170 divided by 2 is 85. And so my perimeter of JKLM is 85. And my perimeter of EFGH, we said was 34. So I'm just going to put that up here. We have EFGH is 34. And JKLM is 85. All right, go ahead and do the practice from lesson 3. Thank you, guys.